Welcome back. In the last video, we compared our VIT feature extractor to our FNet B2 feature extractor in the context of Food Vision Mini. And we decided that the FNet B2 model is probably our model of choice due to its much faster prediction time. It does have a slightly less performance value than our VIT model, but if we're optimizing for the best experience using Food Vision Mini, we probably want a smaller model size footprint and a faster prediction with pretty good prediction performance than a model that takes far longer to perform prediction on a single image and has a much bigger model size. But again, this is context specific. FNet B2 is our model of choice for now. But let's further visualize the metrics that we've got here, hey? We're gonna follow the data visualizer's motto of visualize, visualize, visualize. This is one of my favorite kind of plots to do, is visualizing the speed versus performance trade-off. So let's make this a little bit more concrete of what we're going to do. So we've compared our FNet B2 and VIT feature extractor models. Now let's visualize the comparison with a speed versus performance plot. So we want to create a matplotlib plot with performance, in other words, test accuracy or test loss on one axis, and inference time on the other axis, so time per prediction. So how do we do that? So we can do this, or do so with matplotlib, and then step one is let's create a scatter plot from the comparison data frame to compare FNet B2 and VIT across test accuracy and prediction time. Number two is we'll add titles and labels to make our plot look nice, of course. And number three is let's annotate, because we're going to have two scatter points. One will be for VIT, one will be for FNet B2. And we want to annotate the samples on the scatter plot so we know what's going on. We want to visualize, right? Make things look nice. Make things look pretty and beautiful. So create a legend based on the model sizes. So this is another point. If ever you can make something more understandable, chances are making it visual will often help. So we've got this beautiful table, right? We look at the ratios, but I like plotting things. So let's go through these steps, hey? Number one is create a plot from model comparison data frame. So fig ax equals plt, and I'll just import matplotlib, we don't need to. So import matplotlib .py plot as plt. So plt, I'm going to do it as a subplot. I'll set the fig size to maybe 12.8 or 10.7. 12.8 should be enough for now. Scatter equals ax.scatter, and the data is going to be our data frame, which is of course the data frame that we created earlier. So this data frame, we're trying to compare our model's test accuracy to their time per prediction on CPU. And then X is going to be equal to time per pred CPU. So we're passing in the column name there. So time per pred on CPU is going to be on the X axis, and then our Y axis is going to be the test accuracy. Then we can pass in another variable here, which is C. C stands for color. I'm going to pass in a list for blue and orange. You can pick other matplotlib colors, but blue and orange stand out to me. And then size is going to be, oh well, we pass this in as a list, by the way, so that each one of the samples in here, the first one is going to be blue, FNet B2, and the second one's going to be orange. Then S stands for size. We want our scatter plot, which is a dot plot, oh, excuse me, missed a bracket here, to be sized in the same ratio of the model size. We'll see what this looks like later on, but it makes a beautiful visualization. Number two, there's our plot. Actually, what does this look like? All right, So there's our VIT model, orange. There's our FNet B2 model. And here's the prediction time per image, and here's the test accuracy, but that doesn't look too good. So this is why we're going to start making our plot beautiful. So let's go here. Number 2 is add titles and labels. Titles and labels to make our plot look good. So we want ax. I want to set the title to be Food Vision Mini. What's a good title for our plot? Food Vision Mini, inference, speed, versus performance. Nice and simple. And we'll set the font size equal to 18. That looks pretty good. And then we're going to go ax.setXlabel for the X label. Prediction time per image in seconds. And then I want the font size for this. Maybe we'll set that to 14. And then we'll set the Y label while we're here. Y label is going to be test accuracy. And this is of course in percentage. I've got the font size here to be 14 as well. And then we can go ax.tickparams. So these are going to be all the little ticks along here. Tick, 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 tick. I want this to be axis. Do we need this one? Equals both. Oh yeah, this is, so we want this as a grid. And then label size equals 12. Oh, 1, 2, 3. Oh my goodness. Too large. So this is going to be, yeah, the labels here. We'll make them a bit bigger. Isn't that looks better already. Now, we'll get the grid. This is the grid I was talking about, by the way. Just so we can see where things are. We'll get some lines going. Beautiful, look at that. Much better. So what was number 3? Annotate the samples on the scatter plot so we know what's going on. Yeah. So here's where we want to label each of these. So we don't know which one's which, right? They're just different colors. So 3, how can we do this? So for index row in df.iter_rows, I want to, so this is going to iterate through the rows in the data frame here. I want to ax.annotate, annotate, text equals, so I'm going to show you an error on purpose here. It might not error in your version if you use text, but just to, I'll show you what I mean in a second. And then the xy, so the annotate parameter here for the axis, if we look up this, matplotlib annotate, it takes in some coordinates for where we want to label a plot. Yeah, annotate the point xy with text. So see text. However, text in other versions of matplotlib might also be S for string. So just keep that in mind. I'm going to use text and mine will error in Google Colab as far as I know, but if yours errors when you're using text, use S because matplotlib changed this a while ago and some different versions use different things. But what we're trying to do is just annotate a coordinate, so this coordinate and this coordinate with FNet B2 and VIT respectively. Well, actually, this one's going to be FNet B2, this one's going to be VIT. So the coordinates we want to label each point will be row, time per pred CPU. So this is X and Y, and test ac. And then finally, let's make the size equal 12. Let's see what this looks like. What have we done here? Maybe this needs to be in brackets. Yes, it does, because this is a tuple. So this is the X coordinate, and this is the Y coordinate. What do we get? Ah, there we go. There's that error I was telling you about. So in some versions of matplotlib, this is text. In my current version on Google Colab, it is S. So import matplotlib, and then I'm going to check the version, matplotlib version. This is what I'm using in Google Colab. If yours is different to 3.2.2, text might work for you, or S. So let's see what this looks like. There we go. Well, that's a little bit overlapping, so maybe we adjust this. We're going to add some value to the X coordinate, maybe 0.06. Because why are we doing that? Because of the scale of here. We just want to move this over a little bit, move this over a little bit too. And then we can do the same for the test accuracy. This is going to be a slightly different scale. We want to move it up a bit. So maybe 0.03. How's that look? No, that's good enough for me. Yeah, that'll do. Now, we've got step 4. You see how our plot's coming together? Now we want to create a legend based on the model sizes, because right now our dots are different sizes, but we don't know what the different sizes are. Well, we do because we're creating this plot. But what if we wanted to share this to our team and go, hey, this is why we chose FNet B2 is because it has a far lower prediction time per image, but its test accuracy is still quite good compared to VIT. So we want to make sure the plot is as annotated as possible so people can understand it if they're just looking at the plot. So we can do this by creating a tuple of handles and labels equals our scatter element. So our scatter element is up here. Scatter dot, we're going to go legend. We'll get the legend elements from scatter, and this is going to be prop equals sizes. So what this is basically saying is, hey, scatter, give me the property of size. So we're extracting the legend element of the property size from this variable. This is what that's saying there. And then I'm going to set the alpha to equal 0.5. That's going to be the opacity of our legend. Let's see what this looks like in practice rather than just talking about it. Model size legend equals ax.legend. So this is saying, hey, set a legend on this axis, and then we're going to pass in the handles and the labels. And then the location is going to be in the lower right because that just seems like the best place on the plot to be. Instead of upper there, I want it down here. I want the legend down here. Does that need an underscore? No, it doesn't. And then title equals model size megabyte. We'll see what this looks like in a second. And then the font size here again is going to be 12. Let's see what this looks like. Wonderful, look at that. How good is that plot looking? Oh my goodness. Now, save it if we want. Save the figure so we could share it. We're going to a meeting for the Food Vision team to showcase our work to all of our fellow colleagues. I'm going to save this as Food Vision Mini Inference Speed versus Performance.png. So we need to go to the meeting and we need to show them what we found. We need to explain why we're... Oh, what's going on here? Oh, I'll just save it to here. There we go. We need to explain the experiments we've done. We want to allow people to test our Food Vision Mini application. And we're going to have to say, you know what? We chose EfficientNet B2 to deploy because it's of a far smaller model size. Its prediction is much faster, but its test accuracy is still very good. It's not quite where VIT is, but we're optimizing for prediction time per image for the best experience. So a slow app is a boring app. Now, if we come over here, look at that. We've got this. So we could share that with some people. Now, of course, you could plot the rest of your models on here if you've done other modeling experiments, but this is one of the most powerful ways to visualize the speed versus performance trade-off. And so, like all good cooking shows, I've got a slide prepared for this. So we have performance versus speed trade-off. So our most ideal position, you might have guessed, is right up here in the top left. We have the highest test accuracy possible, but the lowest prediction time per image. So, with a larger model, so our VIT model has a larger model size, it comes better performance, which is exactly what we see. Our VIT model has more parameters, has a higher learning capacity than our FNet B2 model. It performs better on the test accuracy. But this is in our case, at the sacrifice of speed. So although it performs better on the metric scale, it takes longer per prediction. So that's the speed versus performance or performance versus speed trade-off. It isn't always the case, and there are researchers and a lot of different techniques coming out to move this dot towards here and of course, increase this up to here, but that is something I'd leave for you to explore as some extra curriculum. So that's the most ideal position, but for now we're going to run with this because we are optimizing for prediction time per image. So with that being said, I think we've completed our task of Food Vision Mini model deployment experiment outline. We've gone through this experiment. We've got a model that performs well, and we've got a model that performs fairly fast. It's not quite 30 FPS or 30 milliseconds latency, but it's good enough to go forward. So let's, over the next few videos, start to make an interface or a demo to deploy our FNet B2 feature extractor and bring Food Vision Mini to life. So if you're up for the challenge, join me in the next video. I'll see you there.